what you see with the right eye cannot be seen any longer. And you need to find a way to complete it. So when they see this screen on the right part isn't simply there. And one of the systems we have is to concentrate the screen on the visual, in the left visual field. Same with sounds. We can perceive with both ears in a stereo fashion. But the right ear information of these people who've neglected doesn't exist. So you need to work on the left side, on the left ear, so that they have a channel where they can hear everything. But of course, the source of the sound comes from the right, so you need to accommodate for that. Tutorials. Tutorials are support materials, in this case visual. And this is very common for the elderly. How to put on your shoes or tie up your shoes. Some people can do many things, but they can forget every so often to put on their shoes properly, and they need this tutorial. Then they remember this for quite a while, then they forget again. You need to have the tutorial again. And sometimes they need more steps to complete the task, and the system must adapt the abilities and the capacities of that person to know exactly how many steps are necessary for each step. There are several types of tutorials. We have the dressing up tutorial, which changes depending on the season, but also changes on the basis of hours of day, or on Sunday or weekdays. When people go to Mass, they do not wear the same as when they go to the gym. Here, to prepare the dough for pasta, one of the patients being Italian in this case. To prepare dough isn't the same in Italy as it is in Germany or Spain, because the cooking at al dente, the concept is not the same in Italy as it is in Germany or in Spain. And there are 35 different pasta varieties. For us, pasta is everything. But in Italy, linguine, spaghetti have a different cooking time. Also, being able to prepare your own coffee is very important. It's coffee for them, warm. It's never kept in a fridge. Grooming. Grooming is also important, as well as the daily chores around the house. There are several resources, and here we need to play about with the different tasks. The shared technology is characterized by being custom-made or custom-adjusted to the user. This is the tape that you may not be able to see. No, clearly not. It's a walker video. Yeah, I walker video in the campus north of the University of Catalonia. It's a 75-year-old person whose pathology is that 20 years ago, this person jumped from a moving train, and he broke a leg. He doesn't need the walker, but we've asked him to help us because his lameness is important. So you cannot see the tape, but you will see this in actual operation later on. The medical analysis is that the walker has a type of wheels which make it ideal for inside and outside promenades. It is adjusted to the height of the user. You can adjust it, but one thing you'll see in this picture is that the position of the arms is correct for somebody who's pushing something. The walker they were pushing weighs 25 kilograms in an uphill slope, 6 to 8 degrees. To push uphill an elderly person, 25 kilos is a lot of weight. If the machine weren't helping them, you'd see a more forced posture. In this picture, the position of the feet is correct. If they were pushing, you would see the legs in a different position, and the back of the user is straight. If they were pushing, they would that back would have been curved. So now we are seeing the same thing, but in a downhill descent. The position of the arms is semi-flexed, and since it's downhill, it's an 8-degree slope at the exit of the library. So what we have here is that the person is not stopping the inertia of the downhill walk. The walker is being braked. There are two supports here. So one, it helps us going uphill, but without pulling, simply pushing. And in the downhill walk, it's braking. The user, therefore, is more comfortable. Now Antonio will talk about the walker. When we were invited to give this talk, we wanted to bring the walker to give you a demo. And I'd like to mention the importance of these walkers for the elderly or people who had some sort of problem, a vascular problem or trauma. The first thing we want when they have been bedridden is to go back to the autonomy we had before. So walkers are essential because this is the first thing we need. If we cannot walk on our own, at least to walk with some assistance. This is the physical part. But then you have the cognitive aspect. So walkers, if there has been an accident, can help us regain our autonomy. But they can lengthen our being bedridden when we grow older. This is one of the projects to prevent being bedridden for as long as possible, maintaining our personal autonomy. So when walkers we realize that walkers are important. So it's not a traditional walker. It has onboard computers, it has motors, etc. We cannot see the PowerPoint presentation. Can we please? Just a brief mechanical explanation about this. We believe that this reflects the totality of any displacement with a walker. A flat surface, having to go uphill, downhill, turning. When we grow older, uphill is more difficult. When we go downhill or when we turn, we may have a problem with our hand, the hemiplegia, for instance. It may be necessary to provide help. So what I'm going to show you is how this walker, by means of a number of devices and by means of some forces strategies with the torques necessary, help the individual carry out a certain task. So for pedagogic reasons, in order to do this maneuver of going up a ramp, we have these initial forces, the initial force to start the velocity and the acceleration. Then there is a ramp. Then you need to turn. These are forces which depend on the path. Then there is a resistance, the friction of the movement. So these type of forces, both spatially and time-wise, they are displaced. You need the initial push, then you need the uphill exertion after the initial push, then the turning, The turn is perhaps the left hand which needs to make the force, but it's negative force because you need to retain, you need to stop, otherwise the turn would be continued. And then the resistant force, which is constant. So this is the profile of the left hand when you're doing this very simple maneuver. The ideas we have is to use some strategies to these forces, and you need some sort of device to do this. And you need sensors as well for the walker. The sensors we've used are based on putting 8 sensors in the handles. We are used to see this in the marketplace when they put things on a balance, on a scale. This is extensiometric gauge, something that measures force. We have 8 of these gauges, 3 to detect, or 2 rather, to detect the normal forces of the floor, to prevent tipping over. And in spite of the the different forces are different. I mean, when you're going down, the center of gravity displaces. When you're turning, things change as well. So the whole idea is for the pathway forces to apply a certain factor which will be controlled by the doctor, and this is applied to each one of the hands. You might make the walker used by somebody who has different forces in their hands. Then you'd get the gauge balanced accordingly. With this system, you could do that even if the person has different strength in both hands. Lambda means that the force you have to do is less, and it is controlled by the doctor, by the physician. Okay? Then you have the resistant force, in which the doctor would recommend as a stimulus for exercise, apart from walking, because you already got the stability, to do a bit of exercise using another factor, the new factor. With new, you should make some extra force to stimulate your own physical